TK, the science guy.
TK, the science guy.
TK, the science guy.
Apes rule.
TK, the science guy.
Wind power, I'm a big fan. TK, the science guy.
TK, the science guy.
Hey CW Bio, Mr. Kennedy here again. Today we get to do a very special activity to learn a little bit about how enzymes work. It's called the need for speed. If you go to our class webpage, look under all the handouts for biology there, you need to find the one that looks just like that, the need for speed. All right, so what I'm gonna do is demonstrate this activity for you. Just like what we've done in the past, it's gonna be your job to listen and to watch what you see and to use what you're seeing here in this table and in this video to complete your lab report. Those of you that would like, you can actually do something like this at home and recreate the experiment yourself. Maybe I'll give you extra credit if you give it a shot. Right, let's get started. To do this experiment, you need 2 cups. One with some dry pinto beans, or it could be macaroni or anything else for that matter. The other one's empty. You're gonna need a tennis ball eventually, and maybe a little bit of masking tape, okay? So the need for speed is all about enzyme action. And in this case, I'm gonna use a very simple activity to mimic how an enzyme works. I'm gonna take my hand and I'm gonna move beans from this cup to that one. I know, rocket science, wow. And as I do that, you're going to need to record how many beans that I move in each round in your data table that comes from this handout, okay? So what we're doing is we're going to have 3 separate trials. I'm going to move beans under the column that says normal activity, where I don't really do anything to my hand at all. I just grab beans and I move them. Then I'm going to denature my enzyme, in this case, my hand, and we're gonna see what happens as I try to move beans at that point. And then we're gonna do something called competitive inhibition. And in each of these, we're gonna repeat our experiment 1, 2, 3, 4, 5, 6 times. You're gonna add up all those numbers, right, to get an average down here at the bottom, and we're gonna compare the results. Make sense so far? Let's get started. Okay, ladies and gentlemen, I'm going to dump these beans out so that we can begin our experiment. I get to move beans with just one hand, 1 bean at a time, from this pile to the cup. I get 10 seconds. On your marks, get set, go. Okay, that's 10 seconds. Now what I'm gonna do is I'm gonna dump this out and you get to count the beans. How many beans did Mr. Kennedy move? All right, it's round 2, cup's empty, pile's been recreated. Here I go again, I get 10 seconds. That's my 10 seconds. How many beans did Mr. Kennedy move in round 2? Round 3, how many beans did Mr. Kennedy move? Round 4, how many beans did Mr. Kennedy move? Round 5, how many beans did Mr. Kennedy move? Last round, how many beans did Mr. Kennedy move? All right, gang, it's time for our second experiment. Take all the information from experiment number 1, make sure it's in your data table, you added all those numbers up, and you have an average. Second experiment is called denaturization. When we denature an enzyme, we change its shape so it no longer works. How am I going to do that? I've got some masking tape. So I'm just going to take this masking tape, and if you remember what I did, I used my fingers to pick up these beans. So if I take the tape and I tape up my fingers, I am changing the shape, right? Changing the shape of the enzyme. All right, so let's see how Mr. Kennedy does this time, okay? So I'm gonna get 10 seconds to pick up beans, and I gotta move them from this pile to that cup. Everybody ready? On your marks, get set, go. I think I got a problem here. Oh, wait, no, no. Has it been 10 seconds yet? Wait, almost got, no. Okay, that's time. Well, I figure you guys probably already know what the outcome of the rest of the trials for denaturization would look like. I wasn't able to pick up any beans. I don't care how much time you give me, how many opportunities you give me. When the enzyme is denatured, when my fingers were all taped together, I just couldn't pick up a single bean. So we're gonna put zeros all the way down that column. We're gonna go on to experiment number 3 at this point. In experiment number 3, we're gonna study competitive inhibition. In competitive inhibition, two substrates fight for the same active site on our enzyme. So in this case, I have two things that are gonna fight for, well, attention from my hand. We've got the beans that I'm supposed to be moving and a tennis ball. In this experiment, I have to hold the tennis ball in my hand, keeping my fingers in contact with the tennis ball the entire time. While I'm holding the tennis ball, I've got to try to pick up beans and move them into the cup. Let's see how it goes. Everybody ready? 3, 2, 1, here we go. Oh, I got one. Oh, this isn't going so good. It's not easy, gang. Oh, wait. There we go. There we go. All right, I think that's time. Round 2. Come on, Mr. Kennedy. Come on. Oh, that was cheating. No, wait, there was one. Okay. Ah, I've got a cramp. My hand. Ow. Wait, there's a half of one. That counts. And that's time. Round 3, how many beans did Mr. Kennedy move this time? Round 4, how many beans did Mr. Kennedy move this time? Round 5, how many beans did Mr. Kennedy move? And round 6, how many beans did Mr. Kennedy move? All right, gang, you need to use all the information that you've seen and heard while I've been doing this experiment to make sure that your data table is complete. Then I want you to answer these conclusion questions in your lab report. Add that lab report to your notebooks and get that turned in. Mr. Kennedy will see you next time. I hope you've enjoyed this experiment, Need for Speed on enzyme action.
TK the Science Guy.
TK the Science Guy.
TK the Science Guy.
Apes rule.
TK the Science Guy.
Wind power. I'm a big fan. TK the Science Guy.
TK the Science Guy.